Hi, Chris.
Hey, how you doing?
Fine. We have an interesting topic ahead.
Yes, we do. It's another one of those nobody can agree topics, right? You
Uh,
know, what is a process manager? How do you deal with transactions? You know,
this is scary. Ain't that a saga or something? Um,
oh God, oh,
oh,
the
sorry.
saga is chain of sequel transactions and is just oh my God, never do it.
Oh, yeah, and
I
it's
mean,
very well described in a specific paper, so that has a specific definition.
well, and the biggest thing is that a saga for everybody who doesn't know is doing a series of transactional commits to different databases that can then be each reversed. So you're undoing the transactions and going back through in order to have a distributed process. The problem, and it just doesn't apply to event sourcing because you always want to be working on a going forward basis, right? Because we have an error of time. There is no, transactions are bad in that they magically stop the universe and do things, right? And distributed transactions try and stop everything to do it. And then the concept of the saga is, well, we're going to magically stop the universe in 5 different places, and then we're going to magically go back and undo it, even though other things will have happened. So the problem is there's no way to actually stop time moving forward while you're in the middle of this. So it's just a bad plan.
Yeah, so how do
But
we
that's
do
not what
it?
we're talking about. That is a tangent.
Uh,
Oh,
Almost.
it's related.
It's related. So, because the thing is, um, I need some kind of coordination from time to time between
Yes.
things. And we have a sample for this one. So let me just share my screen and try to do
Yep.
that correctly. Share. Yes, we
Because
can.
we do have on a very regular basis, constraints that we need to enforce that involve, what would normally be a transaction. It's, how do I move money from account A to account B? How do I move stock from my warehouse into a truck, right? I can't have my system suddenly thinking that I've got an extra truckload of widgets just because it shut off for a second, after I put it in the truck, but before I deleted it from the warehouse, right? That's not okay. I can't assume I have an extra 100 shares of IBM to sell because, I placed those with the broker, but then I forgot about it before I could write down in the other system. These are all variations of the same problem, right? It's I have a fixed amount of X, but that is held by different objects, right? So as we move things around, we need to hold the invariant not just in the one object, but across multiple objects. And the way you do this in a relational database is you do a transaction and you say, and the transaction will take everybody who's reading the database and will go, okay, hold on, stop. I'm going to move everything around. Okay, go. So what we do in event store systems is we make sure that we do a series of atomic commits, right? And we do them in such a way that if everything turns off at any point, we can turn it back on and know where we're at in recovery. So let's move to that next view.
Yo.
So the simplest way to do that, because what we're trying to do here is we can only write events or sets of events in and commit them, right? And so the first way to do it is the way double entry accounting works with a ledger or a journal. And there what we say is that we don't we don't say, oh, I'm going to add 5 here and I'm going to move 5 away from here. We're going to say I'm going to transfer 5 from A to B, right? So I don't have 2 writes, I have 1 write. and that one write goes into a single stream, right? And that's that transfer event you see right in the middle there. And this is the way accounting systems work. And if you need to solve a problem that is fundamentally an accounting problem, this is a great way to do it. Does have some downsides. The upside is it's a well-known pattern. Everything is there. It's atomic. You can't screw it up because you're only saying we're doing a transfer from A to B. Well, you can't screw up the rights. You can't miss one, right?
Yep.
Obviously, you have defects and do the wrong thing. One of the challenges, though, is we've got in this example, let's walk through the example, right? So we've got our transaction stream. We're just going to look at Monday here, right?
Yep.
We open Monday in the morning. We have opening balances on A. We add B, right? And an account create event has no balance. And now we're going to fund B. So we're going to transfer from A to B. And then at the end of the day, we write a closing balance and we open the next day, Tuesday. So that's this next stream. And now the opening balance there is 900 and 100.
Yep.
So these green boxes are the read models. So location A has 1,000, location B has nothing. Then after our transfer, immediately we read that event and our read model changes from 900 to 100. One atomic change, right? Really nice. And then as we open Tuesday, the opening balances give us that same difference.
Yep, fair enough.
So some of the problems with this is all of the locations need to use the same transaction log. So once I have 100,000 locations, this gets a little big, right? And that's why we called out the daily transaction stream and the closing the balance. This gets into the closing the books pattern, which is a little bit different than this. The key in the closing the books pattern is we take the entire store and we archive it. And we do this little pattern on a grand scale. But here, we're going to break this down into whatever period makes sense. It could be yearly, it could be quarterly, could be daily, weekly, whatever. But we're doing that because these streams get really long and we got to do very aggressive checkpointing and caching to do this.
Yep.
The other thing is that this stream has all these transfers in it. It's not really a good place to talk about any of the attributes of the account. Because all of a sudden I'm putting all of the attributes of the account, like is it open, is it closed, is it owned by Bob, is it under scrutiny, is it a, or if we're in a warehouse, will it only hold items of this size or end pallets, or is it in the freezer? I mean, they get freezer warehouses. Right?
Yep.
I worked in one as a kid. They're really cold. So all of that doesn't really belong because the pace and the change of that data is very different than the pace and the change of the transfers. If you put all the information like, hey, this location is in the freezer and this location's in the main warehouse, and then you apply 10 million in and out transactions to it, you've got to scan all the way back to the beginning to find that.
Yep.
Makes a lot more sense to say, no, this stream here describes location A, and this stream over here deals with the transactions of things moving in and out of A. So if you join those together, this can be a very workable model. But you've got to make sure you're careful in how you set this up.
Yep. So we have alternatives.
Yep. So that's number one.
Yep.
Number two is what's called the write-ahead pattern. The write-ahead log. And what we do is we write our intent. So our intent isn't really clear here, but basically we're saying, I'm intending to move something from A to B. So we write something that expresses our intent and ensures that this can happen. So if I reserve 100 items from A, I need to enforce that nothing else can ever use those 100 items until that reservation is completed. Now, it might get busted and then I get them back, or it might be completed and then they're gone, right?
Yep.
So one of the things you're seeing here is that, so we want to move from A to B, same problem, location A, location B. What we do is we do a reserve, we do an apply, complete the reservation, complete the application. Because the truth is, the target might not be able to accept it. I might say take 100 pallets from this location and put them in this truck. And the truck might say, dude, I'm full. Or, hey, I broke down. Or, I'm in New Jersey. No, you can't move stuff from your warehouse into my truck. My truck isn't there, right?
Yep.
And that would bust the transaction. Or the location might say, I've only got 5 units here. I know you told me to move 100 units in the truck, but there's only 5.
Yep.
You can't reserve that much, right?
Yep.
The reservation completed and the application completed should not be allowed to fail. And if they do, they need to raise a big alarm.
Yep.
Right. So what that does is that gives us more implicit variables. We don't need these in the aggregates or in the streams or in your objects. But what we're saying is that we've got now the concept of units that we want to turn units, available units, and pending units.
Yep. And that's
right?
in the internal state of the.
Right. Because until the reservation is completed, location A owns the units. So the ownership of the 1,000 units until the reservation is completed is with A. Right. But not all of them may be available. Right. And so that's what we're showing here is that I reserve it, my available goes down. Any rules about additional reservations need to read available and not total.
Yep.
Right. And then, and so we have 9 available, 9 are reserved. And then we go to B, and B actually, so we should have put pending in that box, but oh, what, we missed it. Right.
Yeah.
So, and then B has 100 pending, and then we just close it all.
Yep.
Right. And we've got a nice little write up here of the actual, the way that would be written in a standard approach. So we get A, and then we reserve it and we save it. And that save writes this event. And then we take B and we apply it and we save it. And that writes this event. Right. And so you'll notice that we take an action and then we save, and we take an action and we save. Right. And if we don't save, the action to the system never happened.
Yep.
Right.
So the save writes the events to the stream in question. Appends them.
Right. So my in-memory microservices can do whatever they want, but it's not real to the rest of the world until they commit it to storage.
Yep.
And the rest of the world's going to read it from storage. And so that's what that save is all about.
Yep.
But if you look down this, if you took a line across at any point, we could have a power failure and we come up and we can say, oh, hey, we've got a reservation and it was never applied. It was never completed. So I have an incomplete reservation. I have an incomplete application. All right.
Yep.
And so I can use that to have one piece of code that every time I start up or every time I want a health check, it just watches that.
Yeah. I'm gonna move to the next one because.
Right. So this talks about how the system would track those transactions. We don't have any more events, right? We're only using these 4 events, and they're really small. It's like reserve, apply, act. Tiny, fast little things.
Yep.
Completely independent. But from there, we can tell how many open transactions we have. We can tell how much is pending, how much is moved. We just calculate all that in the read model.
Yep.
And I can have something else watching all of that and deciding to repair it, reporting on SLA. I can have all of these rich metrics on this, very similar to what we're doing in the other account. If we did want to do a pending step, we could do it in the journal by adding a third account.
Yep.
And we would transfer into a third account, and then we transfer from the third account back to the first account. But generally with that system, you don't need to.
Yep.
Right. With this system, because we're doing things separately, we can create all the information off these really tiny pieces.
Yep.
And that's a really key element here is a lot of people lose the fact that the amount of information you can generate from the state of what occurred in a really third normal form tiny event is huge, as long as you structure everything correctly. And while this will work technically, if these two streams are in different stores, all of this gets much harder, right? And I would say this pattern is only suitable if the two logs are in the same, if the two streams are in the same log and they have a guaranteed shared order.
Yeah, that's because of the shared ordering. That's important.
Right.
So,
because now I don't have any questions about did the reservation or the application happen out of order, right? Whereas if these are not in the same system, things can get really wonky. It can get really hard to be provably correct about this,
yep.
right? So, and then that.
Lost him again.
Oh, and the delay sound so you're talking about the.
Yeah.
Okay.
I lost you for a minute.
Yeah. Okay.
You were we were just talking about, okay, this this model is fine as long as you stay in the same log because everything is in
Yep.
order and you can process everything in order for any tracking, repairing, whatever you want to do, which is super fine. But then we have the problem of, yeah, different services having their own storage.
Right. So generally, the way you solve that is we go back and we take a page out of the book of the ledger. Okay. So in the ledger, we said, okay, we're going to write events into this ledger log, which are the transactions, and it is the only thing we have. But now we're going to sort of combine the two, if you will, right?
Yep.
And here, rather than having one ledger stream with all the transactions in it, I'm generally going to create a stream for this transaction.
This one.
Right. So this is how we manage more complicated scenarios or scenarios where we're pulling things from different locations. In this scenario, this will work fine if all four of these things are in different systems, right? And what we do is the move event creates a transaction, it's a transaction management service. It creates a transaction, and that transaction manager, aka a process manager, begins driving this transaction, okay? And what we're going to do here is we're going to use the same write-ahead pattern that we used in the implicit write-ahead in the shared log. And now we're going to have a dedicated stream for this process, and every single step in it is going to be in a write-ahead pattern.
Yep.
So I'm going to say I started, and then I'm going to say I'm reserving funds, and then I'm going to go and try and reserve them. Then I'm say, oh, I reserved it, right? And now I'm saying, okay, now I'm going to try and apply them, and then I'm going to come back and say, okay, now they're applied, right? So we've got the same inside the two streams. They have the exact same events. But now we have an external stream that's explicitly recording the attempt to do each one of these steps.
Yep.
And the reason that's important is it allows us to do things like add in this additional step where now we have an external approval. And let's say that's manual, right? I'm going to say I'm requesting approval, and now sometime later it gets approved, right? And now I can go back and respond to that. So this transaction manager here that's managing our transaction or our process, what what gets people a little, they have this rule in their head that an aggregate or a service responds to a command and produces events,
Yep.
right? And the transaction manager is actually not doing that. It's responding to commands, it's responding to events.
Yep.
Right? Now, it can't throw an exception on the events occurred, but it can take all sorts of actions on it. Right?
Yep.
And one of the great things about it is if you think about, we don't need to go back, but if you just think about the previous pattern, the logic for what happens with reservations applications is split between the two locations.
Yep.
Here, all of the logic and all of the recovery is in one place. So if I need some sort of complicated recovery scenario, or I want to do that saga pattern we talked about, this puts all of the logic on one recoverable, monitorable, and auditable place. So anything I'm going to do that's really complicated, this can expand to cover all those cases. It also provides a really simple, really clear audit experience.
Yep.
It provides really great durability and recoverability. So if you want high availability, HA, disaster recovery, DR, this will allow you to fail and recover. Cloud scenarios where you assume things are unstable, this works like a champ, right? And so maybe it's like this is a payment.
Yep.
Right? So maybe rather location A is my inventory and location B is my shopping cart. So I'm going to reserve 10 units from inventory. I'm going to apply them to the shopping cart, and my external approval is a credit card gateway.
Yep.
Right? So inventory knows, okay, well, I've got this many units reserved for this shopping basket, right? And so on and so forth. And I'm going to do all these things. And this allows us to have one place. So I could, and this is what Amazon does, I could right here after requested approval, if that was request payment, I could then return to the user and go, your order's all set, but still finish the process offline.
Yep.
And that's how AWS has the fastest payment gateways in the West, right? Yep. You never have to wait for your credit card to be processed, because what they do is right after requesting approval, they send you an okay notification on the stream. And if the payment fails, they will send you an email asynchronously after the fact. They actually don't even actually reserve the inventory until after your payment's processed, but they'll put a soft reservation on it, or they'll warn you, hey, stocks are really low.
Yep.
The reason why they say stocks are low is they're like, we're not even going to reserve your inventory until we know you got your money. But we're going to tell you this is all fine. This process manager supports all of those scenarios in a very simple, understandable, and provably correct way.
Yep. And nice thing in this case is that you can actually change the process with minimal impact or no impact on the rest.
Exactly. Right. The events inside the approval, the events, they don't change. Right.
So I can add steps, eventually remove some steps.
Correct.
At will.
Yeah. Maybe the customer, like we say, okay, we're not going to allow you to have if this was a shopping basket in the inventory, right? So location A is inventory, location B is a shopping cart. But we're not going to allow anyone to put more than $1 million of inventory into a shopping cart without talking to a human. Because we're just going to protect ourselves from bots or open to the internet. We've got a limit. So we might not be able to apply this. So we could invert this order and say, ensure that the shopping cart can accept this request before I even go and see if I'm going to pull it out of inventory.
Yep.
Right? Completely reorganizing the steps here. And all the logic is really straightforward. And I can actually, for that, I could have a transaction types because every transaction is its own stream.
Yep.
Right. So I could have a pre-approval transaction manager. I could have a gold customer transaction manager and give people completely different experiences with the same fundamental events in the system.
Yep. Because the
Um,
process is slightly different. But there's one thing also on modeling side is that the what's interesting, what we call here transaction, is actually a business.
yes, it's a business process.
It's a business process and has a name, has certain steps, can be eventually in the system broken down into smaller for convenience, and has a stream.
Right.
It has a right of existence.
Yeah, it has an identity. Two transactions with the same information with different IDs are different.
Yep.
So it is an entity. It is its own thing with a life cycle.
Yep.
Right. This also allows you in the other thing when just in terms of designing process managers and managers in general is don't be afraid of the what I call the iPhone approach, which is if it screws up, call a human and be prepared to send them an iPhone with a sorry note.
Yeah.
Right. And a great example that Greg uses in the courses, that's Greg Young in his original CQRS event sourcing course. He talks about thinking about snowplow sales. In North America, most of the snowplows in North America are made in Canada because Canada uses a ton of them. They use them hard and they wear out. But the United States buys a lot of them. We don't make a lot of them, but we use a lot of them. We buy them. So we're like, 20% of the market. So when a city or a town buys a snowplow from someplace in Canada, it has to get driven down to the United States. So think about what happens if we have a snowplow is bought by Detroit, right? And it starts in Ontario, 1,000 miles away across international borders. And it's all the way down in New York State. It's 600 miles closer to its destination. And the city calls up and goes, "Oh, that's not what we ordered. We ordered something else."
Yep.
Right? You can't do a saga reversal, right? The truck is in a different country. You've paid for a driver. He's probably got a hotel room, right? You can't magically make it not happen. So what do? I mean, as a business problem, you probably raise an alert with the sales rep, and he's probably going to get on the phone and go and call his other accounts and go, "Hey, do you need a Model 592? I can give it to you for 20% off, and I can have it there tomorrow."
Yep.
And so he's going to tell that driver to drive to an entirely different city. And this kind of process manager will allow you to do that, right? Because it's just going to phone out, and then we're going to have a redirection event that redirects the, so it'll say, okay, well, Detroit isn't going to get it. Troy is going to get it, right? And Detroit and Troy don't know this all happened. They just know they had an order canceled and an order placed, and they're done.
Yep.
But the process manager knows all this crazy crap happened.
Yep. That's cool.
And then that I love the snowplow because it really highlights the weakness of this mentality of, I can just reverse my transaction, right? Because it assumes that it's immediate and it assumes that nothing has happened in the quote unquote real world.
Yep. Yep. The same for that's a discussion that comes up quite a lot, especially in warehousing samples where I need to make sure that if I move 10 from here to there, people scanning the thing can only say 10. And it's like, yeah, but what if you drop the box and it needs to go in the trash?
Shrink. I mean, the industry has a name for it, and they call it shrink, right? It's like, we had 10 and now we have 9. And our inventory shrunk and we don't know why. It could be damage, it could be theft, it could be all these things.
Yep.
And so you need to be able to apply adjustments to it. Or it might be, I move 10 from here to here, I go here, there's 9. But when I do my audit, I go back and I find, oh no, we left 1 back there.
Yep.
The guys didn't make the move.
Yep.
So it's much better in these systems to model the move as the inputs in the warehouse.
Yep.
Right now, if we go back to, go back to the previous one.
This one.
One more.
One more. That's the 2 stream or the ledger.
Right.
Yep.
So now let's same pattern, different names. So now reserved is move requested, and applied is goods received.
Yep.
And then move completed, receipt completed. So now what we're saying is, hey, I want you to move 10 to here. Oh, hey, I just got 10. That's why I applied. Right? In that case, we don't need the completed because we're tracking the real things.
Yep.
So what we can do is a 3-step. All right. So we say, request the move. The move, they arrived here, got them. And because I got them trumps the completion. So apply and apply completed happen together.
Yep.
Right. And then the reservation completes.
Yep.
And that's a way to model the warehouse. If you want to do a warehouse with scanning, that's the way you do the scanning.
Yep.
Right. You send out a work order. You probably actually have the transaction manager because you're going to have a work item queue on the picker. So the picker is the name of the person that picks things out of there and puts together orders. So you're going to have a picker and you're going to give him a series of move events. So it's like you're going to be like added move. And then the picker's going to go, got them from here, put them in here. And he's going to scan them out and scan them in. That's the way to set up that warehouse. The warehouse really would operate much better if we go forward to. If you really want to start modeling the people and things not arriving, you really want to do this transaction manager on the move.
Yep.
And the approval here is going to be the pick list.
Yep.
And things reorganize.
Yep.
Is it clear that the transformations that happen with the same pattern to accommodate these different scenarios?
Yes. It's very clear. There's probably one thing we can do is having some code sample because we did add here some yeah.
So monitoring and recovery, yeah.
No, I mean the pseudocode here.
Right.
But I think we can probably add some real life sample with this one, simply enough to show, hey, this is the mechanics in code. And since we have
and the code is really simple and it's procedural and it's single threaded, right? Every single one of these, we can have this as a fully, this is one of the brilliance here, right? This can be a fully asynchronous, long running process with every single actor in it being a simple, procedural, single threaded system.
Yep.
It just responds to inputs and does one thing, writes it down and shuts itself down. And if you cache them in memory, they are going to be lightning fast, right? You don't want to reload this transaction every single time if this is going quickly. If it's going slowly, sure, put it away, bring it back up, because this could take days or weeks or months, right? Or it could take, ticks, right?
Yep. 10 seconds to complete the move from 100 boxes from A to B.
Right.
That would be difficult for the people.
Yeah,
so,
exactly.
Let's go back to, so we wanted to move from A to B. We went to A, we can have ledgers, which is fine, but has some drawbacks because you need to close the books and it's kind of, you miss.
Your streams can get very long. You don't have a lot of information. As a sidecar to a richer model, this can be very effective, but you need to make sure that you are careful on your grouping, your data retention, and your speed.
Yep. And then general pattern, reserve, apply, complete.
And this is where I start.
Yep.
So this is my default go-to is I just use, intent and completion. I'm going to do this. I did this in the streams. And I do this first because any process manager I do next, if I'm going to get more complicated, will use these same core events.
Yeah. And since most, let's be honest, most of the system we built are a huge amount of coordination happens inside the same log. So this is fine.
Yeah. I mean, and this is going to work for tons and tons of cases.
Yeah. And you also have like opens up possibilities for tracking.
Right. So we can now deal with things that so the other thing with the ledger is the ledger cannot deal with, let's stay on this for a second.
Yep.
Go back to the last one.
The first one.
No. The monitoring one.
This one. Yes.
The next one. Sorry.
I was on it.
This here, right? So back one.
I'm going in order, forward and backward. Back?
I think it's just remembering your clicks. So too far.
Oh, okay. No, say no or yes. This is going to be funny when people watch this.
I want to look at the monitoring one on so number 4, I think.
Yeah, this one. I think we have a delay with your screen.
There we go. So Miro is being real slow today. So if you think about it, the transaction approach as a limitation is not suitable for things that take time to complete.
Yep.
Right? Because it has in it implicitly that transfers are atomic and immediate. So it has that nice property that everything, but it doesn't model the warehouse.
Mm-mm.
Unless you have a separate account where it's like, oh, I'm going to transfer, so, you put in the forklift,
Yep.
right? So I'm going to transfer from this bay to the forklift, immediate. And now I'm going to transfer from the forklift to the target, immediate, right? But I can't do A to B.
Yep.
Right? I can't extract out or say the forklift isn't important in my model. Here we can, but it gives us all the reporting information. We have ability to do things across time. We can report on status. We can track things, and all of our recovery code is the same.
Yep.
Right. My startup code, my recovery code, my SLA code is one code block. It just scans for open and broken SLAs and then does recovery.
Yep.
So I only write it once.
Yep. And by the way, this one also allows to have like a nice monitoring string that says this is the state of the transactions.
Mm-hmm.
Probably listens to a bit more to have a complete picture.
It says you don't lose anything. You just gain with this one.
Yep.
And this one here, I don't need to go read from multiple places and understand who might be participating. Here, yep. Everything is like all the code to do this is right here. When I wrote this and I come back in 6 months, this is way easier to understand than trying to go, okay, well, let's look at everybody who consumes an applied event. Okay, let's look at everybody who consumes a reserved event.
Yep.
Right, because that's what you're going to do in the first one. Right, so if your domain is kind of simple, that could be fine. But as soon as we start adding in additional things, you're scanning the code to find, participants you didn't expect.
Yep.
Whereas here, everything is detailed in one place, and you do it. And your audit's simple, and your recovery is simple. And generally, you can put the logic to do recovery in the same service.
Yep.
And then I can swap out different managers. I can do a different management process to achieve the same goal for different business reasons.
Yep.
Right.
Cool. So that was process manager in half an hour.
Yeah.
Yeah.
And transactions. We saw transactions, process managers, coordination. all right there, and it's all the same pattern.
Okay.
The biggest barrier to understanding this is the fact that you need the visuals.
Yep.
And you need to see how they all relate, because the words just talking about it don't really bring it forward.
Yep. Cool. Thank you, Chris.
You're welcome.
And see you.
Enjoyable as always.
Yeah, thanks. Except for Miro being slow and internet being slow as well sometimes.
Yeah,
Okay.
we'll fix that in post.
Yeah.
We'll just edit those things out.
Yeah. Okay. Thank you, and see you next time.
All right. Bye.
Bye.